Hello everyone. Now we will take a look at the task number 2 of week 73 of the weekly challenge, and the task is about smallest neighbors. You are given an array of integers at A. Write a script to create an array that represents the smallest element to the left of each corresponding index. If none found, then use 0. Actually, if you will look at the example, you will understand the task a bit deeper because, so let's look at these. So 7, 8, 3, 12, 10, and for each of them we have to find the minimum element on the left side. So for 7 there's nothing on the left, so we put 0 immediately. And for 8 there's only one element, 7, so the minimum of 7 is 7, and 7 is also less than 8, so we put 7. But for 3 the situation is a bit different. So on the left side of 3 there are two elements, 7 and 8. Minimum of those two is 7, but 7 is bigger than 3, so we put 0. That's the point which is not really explained here in the description, but it's visible from the examples. Okay, let's go next. Next is 12, and on the left side there are 3 elements. Minimum of those is 3, and 3 is less than 12, so we put 3 in the output. And finally for 10, the minimum is 3, and 3 is again less than 10. So we put 3. So the only thing to really not to forget is this 0. You put it if the element itself is less than everything on the left. Okay, so but we will see that clearly in the solutions, and we can go directly to the solutions in the Raku programming language. And let me start with my solution, Raku 2, and here it is. So here is the solution. Actually, there are two parts of this. Here, the commented thing is where I just solve it straightforward, and you can see the solution, and maybe it's wise to spend a bit on of trying to understand how this works. So I'm looping over this array, and I'm taking the current element at the current iteration, and I'm taking the minimum elements. The minimum value of all the elements on the left side. So you see, so this hat prefix just makes the range from 0 up to, but not including the current position. So that we have the current element, we have the minimum element, and if the current is less than minimum, so we print 0. And otherwise we just print minimum. And also this branch works for the first element when there's nothing on the left side. Okay, and here is the compact solution. Actually, again, so the same loop. Basically, it's more or less the same. The only thing is that this minimum is computed twice. So if we know that the current element is less than minimum of the elements on the left side, we print 0. Otherwise, we just print this minimum. Yeah, we have to compute it twice here in the solution, but yeah, for 5 elements in that, there's no difference at all. Nobody ever noticed that. So let me run this Raku already. No, this is Raku Raku 2. Right, so the only thing that I just printed one element at a line instead of comma separated list, but yeah, who cares? I mean, I don't care, because yeah, the result is correct. The numbers are the numbers that we want. Right, going next, Ben Davies, Raku 2. Here's the solution. Okay, let's look at this. So first of all, you see there's this plus. Actually, it's like kind of slurpy thing that reads all the elements from the input and puts them to this add array variable, and there's a restriction that all of them, where all applied definitely to this, are defined integers. If, for example, maybe just Raku Ben Davies Raku 2, for example, ABC, like this is incorrect, right? So we need 1, 2, 3 or something like that. Right. Okay, then if everything is correct, if we've got integers, and then we can iterate over them. So yeah, I think this plus, well, first of all, this plus means a different thing. That this plus, and actually it's a different thing than like plus in regular expression, right? Just keep that in mind. So this plus just makes this makes an integer out of this array, and actually it gets the length of this, and So I believe we can make it a bit simpler. So this dot is redundant. It's a sequence, but the range will work there because it's just the left edge of this range is smaller than the right edge. So it will be working with the range, not with the sequence, and with the sequence, of course. And instead of this, you can omit plus because add array will appear in the context where Raku expects something like numeric. Right, then, but nevertheless, so this range is the range of indexes and we map all those indices to something. Let's look to what. So $_ is the current index, right, and the current iteration. And here is a very interesting thing. And actually, I think I've never seen this before. So, so what it does. So, okay, so here we have a slice, but actually a really interesting slice. So the index is, the first index is 0, the last index is the index of the previous position, the previous to the current position. And then we have it as a separate, so we see, so it's not like from 0 to $_, but it's from 0 to one less than $_ and then again $_. And on the left side we have an array and the current. So basically, right, so, and you see, so this is not an assignment, this is a binding operator. And yeah, so maybe that's a really interesting thing. So maybe, so for example, we have an array A is 1 to 10, for example, right? So here's, well, yeah, there are some data there. There's some data there. Oops, I pressed something. Then, for example, if you want to take the last element, like all the previous and the last, you can do it like this. But you see, so in last, you don't have anything. You don't have anything, right? But if you will do it like this, my prev last is binding, you will get the same result, right? So the check failed and binding parameter prev expected position but gotten, yeah, nevertheless. So we see there's nothing. But if you will do it as in the solution that we are looking at, and there we have like an array, from example, from 0 to 5. Well, definitely you can do it like this, and then 6. You will see magic now. So in prev you've got 5 elements like this. Yeah, so it's the elements with the positions 0, 1, 2, 3, 4, not including 5, and then we have 7 in the, yeah, actually maybe I should do it like this, right? So this copies the code from the example. Now in the last you'll see that this is the next element. So that's a thing that it looks a bit strange for me, and I even don't know if it's reflected in the documentation, such behavior of this binding thing. But yeah, nevertheless, so we just saw that it works. Okay, so, and then if there's something previously to the current position, so basically if we are working with the element on the somewhere in the middle or at the end of the array, but not with the first element, then we can do where is, I believe this ends here, right? So this is the condition, right? Right, so if there's no previous, we just print 0 immediately, right? But if there is something on the left side, we have to check this. And so this construction gives you the minimum. I don't understand why we need, yeah, so this is what I mentioned in my in my solution. I calculated minimum twice. Here it's calculated once. That's really nice. So you can just introduce a variable at the place you need it, and then basically use it a bit later. So, and if it's if this minimum is less than the current element, then we use the minimum in output. Otherwise, we just print 0. Okay, so we can run this solution with some. Where do I take some data from? I believe I have to take it from here, and here is 7. Yeah, so like this. Right. Yes. And the result is exactly the same that is expected. Right, so this solution works, and works really great. So let's go next. Not here, but in the recap. list. And after that, the next solution in this list is the solution by Jan Kurnavic, and this is what we have here. So we have, that's another interesting solution. By interesting here, I mean it's difficult to understand. Right, so it's pure Raku, but it doesn't look like a Perlish program, right? It's kind of functional or whatever. Right, so nevertheless, so in the main subroutine, there are some tests with those data, and then let me just do this. Let me just copy this solution and let's try to understand what it's doing. So I don't want any tests. I want just to run the function, and I want to print the result, right? So let's run this Raku test Raku. So the solution gives the correct result, but how is it achieved? Okay, so first of all, so here is again the slurpy thing. I believe this is the same, right? But it will not be the same if you will do it like this, for example. Oh, it is. Well. Yeah, so all those, but it will work like this, right? Yeah, so this thing is the same, but this, okay, nevertheless, so it's homework for you to understand what's the difference between this plus star and double star as a slurper parameter, but for us it's not important. We're using and then here. Actually, and then is part of the with. Let's maybe docs Raku and then where is it? Here it's an infix. And then operator is close relative of with statement modifier, and some compilers. So you see, so with is a statement modifier, but and then is an infix, so it appears between two operands, this and this, and actually there's another one. I believe if we can actually do it like this, and then like this, right? maybe some parentheses are needed there. No, of course no. But yeah, it's just like this actually. Yeah, but I think I'm just actually. But I think probably you can get something. You can simplify the solution by using this reduction operator, but nevertheless it's still difficult to understand what this is about. So and then, so what actually that and then is doing. So and then returns an empty upon incurring the first undefined argument, otherwise last argument, right? So but it also the important thing is that it topicalizes, right? The result of the left side is bound to $_ for the right side, or passed in as argument. Right, so you see, so and actually we already see this $_ here, and on the left side is the original data. So basically this $_ is bound to this. What we are doing here, this dot is applied again to, well, basically it's the same, right? To the same variable, right? To the same, but then it produces. So produce. There's a good example of how to quickly understand what it does. Somewhere here. Yeah, well, basically, for example, this. So it produces and it uses this. This is exactly the same construction as we see in the solution. You see, so there's the ampersand and there's a reduction operator with some function. There's mean, but here is this like multiplication, and you see, so what it prints 10. It's just the copy of the first element. Then 10 multiplied by 5 is 50, and then this 50 becomes the left side of this ampersand, and it is multiplied by 3, right? So it's not just a reduction operator, but it's kind of reduction applied to the, like here, for example, there are two operands on each iteration, and we are using like 1 is the first element, 3 is 1 plus 2, 6 is 3 plus, sorry, 1 plus 3, 3 plus 3, right? Then 6 plus 4 from here is 10, and finally 10 plus 5 is 15. So this is how it works, if you understood this. But right, so we do that. So we basically we're trying to find the minimum for each position in the original data. And let me maybe show this. So I want to do it like this, right? Yeah. So you see, so there are 5 elements, 7, 8, 3, 12, 10, which are the original data. And for 7, for this position, for the first position, or for the 0th position, the minimum on left, including, actually, I think the minimum including, right? Including the element itself is 7. On the second position, the minimum is 7. On the third position, the minimum element of all the items on the left side, including the current item, is 3. Then this 3 actually keeps going because the last 2 elements are bigger than 10. For example, if we will put it here, this one wins on the last position, right? And finally, this one. So this one is the zip operator, which is applied to the pair creation operator. So we create pairs for all those elements, and actually we can already see these pairs here, right? So the pairs are, the first element, the key of the pair is the original element, and the value is the minimum of the all the elements on the left side, including the current element, right? So okay, so after this line we've got these pairs, and then yeah, actually this is good English, and then we are mapping those what we're mapping, pairs, right, in such a way that so we take key and value, we compare them. So yeah, basically, like, they are called keys and values, but actually it's still values, right? But this value here in the key position is the original value, and this value is the minimum value. And if the current position is the current element is bigger than the minimum, then we use the minimum, right, or not? If the current is bigger than the minimum, then we're using the minimum. Oh yeah, so basically vice versa. If minimum is less than the current element, we're using this minimum. Otherwise, we print 0, right? So yeah, that's the whole thing. Let's run this, and we print the result that we already have seen earlier, right? So that's an interesting, I would say, really interesting thing. There are many things that you can learn from here. Many elements of the Raku design. Really interesting. Maybe it's a bit difficult to understand because it doesn't look like a procedural programming language. But nevertheless, right, really interesting. Jason Messer. Here is the solution with gather and take. There should be at least 1 take, and there are 2 takes here. That's again, so that's like, instead of pushing, for example, to an array or printing it immediately, you can use this gather and take thing to create the sequence, which you can just print in the end. And gather for, so we are looking over the array, and there's a state variable left. We are appending the, so yeah, basically in this left we are building the copy of the original data, but before we add something to that, we check this. We make this check. So actually we make this check just before we are looking, just before we added the current element to the at left. And right, so if the minimum, and the minimum is everything on the left, right? So minimum from everything on the left. If it's less than the current element, we take this minimum, otherwise we take 0. And right, so okay, so let's run this solution. Raku JSON Raku JSON Mes Raku Ch2. Right, so this is the correct result. Good. Going next, Luca Ferrari. Here is the solution. Okay, so I see, so there's the star here for slope thing, and the check. So what it what we're doing here is we are grabbing all the elements which are integers, and then we count how many elements basically are integers, and if this number is the same as the number of the original data, then we think that all of the elements are integers and we can work with that. That's, I think it's a bit like too many words here, but yeah, why not? Right, then we collecting these in, so yeah, instead of gather and take, like we use in push and for, and for all the elements from 0 until the last index, we are taking, so this $_ is the index, so if we are in the beginning of the array, we just immediately return 0. That's like an obvious fact, which is maybe not very well visible from the definition, but actually it always will be 0 in the first position in the result. Otherwise, we're using this, and here we see an interesting thing. So minimum is using inside the reduction operator. And here we have a slice, actually, yeah, so a couple of things. So this one can be completely removed, the selected thing, right? But this minimum is an interesting thing because let's maybe run Raku command line. My A is, yeah, 1, 3, 4. Yeah, I have to make something which is really like minimum, right? And for example, I can do it differently, so I can type it like this, I can type it like this, I can type it like, yeah, like a function, but it's exactly the same as this form, and also it is an interesting thing that I can do it like this. And actually, if I will do it like this, it means that I print it like this, min3, min4, min2, and all the rest until the end of the array. So that's exactly the same, but it works, it enrolls in this construction. Right, finally, if this current minimum is less than the current element, then we use the minimum, otherwise 0. Right, let's run this solution, Raku Luca Ferrari Raku Ch2, and we need some data, and the good thing that it's already there. Right, so it works. Mark Anderson, let's see the solution, one-liner, a different approach. So again, we're taking from the command line, and after that, so kv gives us the loop with just series of pairs where keys are the indexes and values are the values, and then we map, and in the map we're using the anonymous function with signature, and the signature contains two variables, key and v. So again, key is the number of the element, like 0, 1, 2, 3, and v is the element itself, and inside this there's this block where we take the head from the array, right, until and including the current element, and then we grab everything which is less than the current element, right? So current element is also here, and it will not be, I think this +1 is a bit redundant, maybe not, because yeah. So if we found nothing, we return, so from this thing we return 0, and after that we take the minimum of everything. So first of all we take the minimum there, and then we take the minimum here, right? So we are grabbing all the elements which are less than v, and only in this case we can just print the minimum. Otherwise we just take a minimum of 0, which is also 0, I believe. Right, so okay, let's run Raku Mark Anderson Raku Ch2, and we need some data. Right, that's the correct result. Markus Holzer. Right, so the element is there, and during gather, so again, you see, so again, the first element is 0 in the output. That's by default, you don't have to calculate it, or you don't have to make some checks. If we are working on the edge, just print 0. And then we are looking at the elements, or the other elements other than the first element. I think this is a bit redundant as well. So -1 can be immediately replaced with the hat, and plus is not needed here, as we saw. Right, but nevertheless, so $I is the index, and we are taking, where's the gather? I missed this gather, right? So yeah, so you see, so yeah, it's kind of one-liner, and gather is extended until, basically, yeah, again, the same construction, gather for, and inside there is one take, and we are taking either minimum of this, width makes the topic, and we are calling minimum method on this topic, and this topic is this, where there's a range. Actually, it's again, so just hat $I without all the rest, and we are grabbing all elements which are less than the current element, and if nothing left, we just take 0, we topicalize this 0, and we call minimum this. But if it's not, if there's something left, we are calling minimum here, and we are taking this as a result. Right, so I think it will just work. Markus Holzer, Raku, Ch2. Right, it works. Good. Going next, Node. What's here? So that's the description. And here is, again, gather for and take. Right, so that's the straightforward solution, with the only thing that I don't understand why we need the smallest. So we take the smallest element, like the element a bit bigger than the first item. And if then we are looking at each element, and if this current element is bigger or equals to the smallest, then we take the smallest, otherwise the smallest is 80. Okay, so yeah, I don't quite like confident with the logic here, but I see that the whole pattern, gather for and take either minimum of 0, is again here, and so it was Noud Raku Ch2. We don't need any input, and it prints the correct result. Very good. Simon Proctor, expect something interesting here. And right, so okay, so again, so we have KV here, and the same signature here, and so my minimum is, right, so we calculate this my only once, which is good. We take this minimum for all the elements including the current one, right? So and then if it's still less than the current one, then we use this, otherwise it's 0. Good. Probably this current I is not actually needed here, right? Because it will never be less than the current item here. And the thing to notice here is this. You see, so the where clause is using a really nice option, just .all, and all the elements should be here. And also notice a good thing that there's a description here and there's a description here. So if you run the program with incorrect arguments, Raku, Simon, Proctor, Raku, Ch2, like ABC, then you've got a lot of output giving you some information about what actually you have to supply. List of integers to check, and there's some explanation of the whole program. The only thing is this. So if you do not provide any arguments, it still passes the condition. All elements are integers, but there are no elements, and you don't know what's there. But if you will do like this, I believe it will give us the correct result, and it really does. Right, next solution, Arne Sommer, and here it is. Right, so with Arne, it's always like there's this key, which I would skip, and basically the main solution is here. And here we are, again, so you take 0 always as the first element, which is a really good thing that you want to notice by reading and trying to understand the task. And then we iterate over the rest. And you see, so you can also use .end probably it's not really like needed, but it's clear. The intention is really clear here. And then you are mapping all those indices to the construction. Yeah, again, so you're taking the minimum of the range and compare it to the current element and print the output. And here the where clause is if right. So yeah, so you see, so you can use the all in the function form, in the form of function, a standalone function, or just as a method call, as we saw in the previous solution. And also there's a separate check that there is at least one element, which is really good. So we can, I believe, run Arne's solution Raku 2 without any arguments, and we will see some output, right? All the rest is this, and for example, ABC, it should be checked, right? Right, Athanasius, Raku number 2. Let's look at this solution. Right, so let's find, so this is a print array, which I will probably not take a look at, but inside the main function, right, so the same check, but you see, so, well, it's the same but not the same, so there's the method call instead of calling a function, right? So it's basically how you, yeah, it's your interpretation, how you perceive this, so yeah, just choose what you want. There's more than one way to do that, as usual. Okay, so then again we're taking the first element. It's always 0. We're taking the minimum, the first minimum that we have. It's the first element, and after that is right. So there's so we'll looping over the rest of the data. Current element is the element in the current position, and to the output we push the minimum if it's less than current or 0, and we are updating the value of this minimum, right? Right, and then we print the array. Right, so yeah, so and we need some input, right? Raku Athanasius Raku 2, and we need some input. And here is the output, right? And you see, yeah, and that's a really nice thing. So actually, I skipped this print array function, but actually, it does a really nice thing. So you see, it aligns the elements. So there's like 1-digit numbers here, and there's 2 digits here, and you see there's an additional space here, which is really nice. So I don't know how is it done, but I believe it's like we are collecting, right? So we're collecting the widths of the of each number, and then we're using this is in sprintf, right? And that's good. That's really like careful printing. Colin Crain, Raku number 2, and so there's some input. There's 4. Oh my god, what's that? Triangular, comma. We saw some triangular thing. So yeah, basically it's like, maybe let's just do this. Raku this, right? So we've got this. So yeah, and if you will apply triangular reduction operator with the operator comma to this, so what you will have there, let's try to think first. So first of all, it will apply comma between all the elements, right? But the second step is just to create a sequence of arrays of incrementing lengths, right? So it will be like 7, 7,8. The next element is 7,8,3, and so on, right? Right, 7, 7, 8, 7, 8. So yeah, so we see this is what we get here. So yeah, basically it's an indirect loop, right, over indices. Wow. And then this 4 is actually iterating over these sublists, right? Wow, that's amazing, I think. Yeah, I think that's really interesting. And then we just push to the output the smallest integer over the current thing. So this is the list. So basically this current thing is, for example, this one. We make an array out of that. Probably we don't need this to do it explicitly, but nevertheless, then the slice pop, slice min. So we remove the find the min value to the left, not inclusive return. Yeah, right. else, you see, so it's not just 0, it's an empty set. So without the current element, we are finding the minimum, and if this minimum of less than the current element, right, pop removes this from the end of the array, if I'm correct, right? Right, well, shift from the left side, then pop from the right side, right? Minimum, otherwise it's 0, and then we just print this, and notice that really you can add a space here, but probably not here. Right, okay, let's run this solution. Raku, Colin Crain, Raku, Ch2. Yeah, so see, interesting. But I think, oh yeah, sorry, yeah, this is the input, and this is the output. Nice. I like this. Good. And I also see, so also notice this one. Actually, maybe let's see it a bit. Like, for example, what if you do it like this? Will it work? Yeah, but can I do it like this? Right? So yeah, when basically, I mean, when you need it like this. Right. Everything works. Good. Okay. Going next. Let's go next. Next solution by Javier, and here it is. And right. So we saw everything. We only check if this list of integers is non-empty, and then we iterate over the elements. And see, so elements and the end. Elements gives you the size of the array and the index of the last element, right? And basically, yeah, we can remove this and element. Well, yeah, nevertheless, you can make it at least in 3 different ways. Then, so okay, so $I is an index of the current element. The lowest thing is, yeah, so we are taking this slice and we are grabbing, we are finding all the elements which are less than current, and then from them we are taking the minimum, and then nice. There was the empty set Unicode character in the previous solution. Now we have the Unicode infinity. If lowest is infinity, really? Why is it infinity? I mean, if it's empty and you call like aha, you see, I didn't know that. Why is it okay? Why the, so for example, this is 0, right? There's only one. Sorry, let's try it again. This is 0, but this is this is bigger than 0. Okay, so if this is infinity, then we use 0. Otherwise, we use this value. Right. Raku here. Raku. Oops. There's. I think there are too many folders which are empty. Raku Ch2, and we need something. This something is exactly the same. Right, and the result is correct. This is really interesting. So probably you didn't know that this returns you the infinity. Right, so it was Jaldhar, now it's Javier. There are a couple of examples. I see, notice these double parentheses, which means that we are passing this as an array and not as a list. So instead of putting star here, we can just put a couple of parentheses around our data. Right, so again, the iteration $I is the current element. If so yeah, if we already found some smallest so far item, and this smallest is really smaller than the current element, then we use this. Otherwise, we use 0, right? So we took the elements. Now we have to work with the smallest so far. If yeah. Yeah, I wonder if we can just optimize because we are making this check here and here again. So probably that, yeah, maybe not. So if we are basically on the first iteration, if we didn't take anything, we just take the first element. So basically, I believe this one can be like assigned directly to a 0th, right? But will it affect this check? I don't know. And otherwise, if the smallest so far is bigger, then we use the smallest. We assign the smallest, so basically if the current element is less than the smallest one, then, right, the only thing, maybe these parentheses are really not needed. They will make the code a bit more air. They will add a bit more air to the code. Right, let's run this. So Raku Javier Raku Ch2, and there are some data there inside, and the result is the same. Right, okay, Laurent, solution number 2. Here it is. Right, so what we are having here, there's some data. We start with the result. Notice this comma, which is really but is it really needed here? Like, for example, Raku, my result is 0, and so yeah, this is what we have here, and my result is 0, like this. Probably there's no difference, at least in this assignment, right? Right. Then we take the first element from here. We consider this as minimum, and for the rest, so we see there's another paradigm of how you can take the first element and work with the rest. So just remove this and work with the rest. This item is actually, it's not the index, unlike many of the previous solutions. This is the value. And if it is less than minimum, then we add 0 to the result and take this and update the minimum value. Otherwise, we just take this currently existing minimum and push it to the result. Right. So okay. So let's run it. Raku Laurent Raku Ch2. Right. Right. Yeah, maybe actually we can add some bonus points if the result is exactly the same as in the task, but probably not, because yeah, it's about thinking, it's not about just printing. Right. And yeah, and here's the solution of Mohammed, and you see, so the input is not just a list of integers, it's a string containing some comma separated and space separated integers. So we print this, and then we are doing this and print this comma separated again. So by calling this, we prepare a string, right, and print the string. So I expect the smallest neighbor to return an array. This is the fact. Right, so okay, so we take this list as a string, and we are probably going to modify this. What we are doing, so die invalid list and list. So we check it against the regular expression of regex or regex. Actually, in Raku we can add spaces here to make it, again, to add some air to easily understand, to easier understand it. So there are some optional spaces, some minuses before the digits, right? Why is it one digit? Hey, there should be 2 digits here at least, like plus, right? Or I'm correct. Then comma, then space. So yeah, basically this thing in square brackets is just braces or just regular parentheses in the sense of Perl 5 regular expressions, but without capturing, right? And we can repeat it at least one time. So there are some space, some digit, but I believe how this like passes the check. If there's only 1 digit here, then comma, an optional comma. Right, but we will see if it works. Then we split this by we split it here, but here we just remove all the spaces in the string. Then we split it, and we probably can use at here as a sigil and remove these parentheses, right? Because why? And after that, so we keeping this 0 already in the result, which we are going to return. And for the rest, so I is an index. For the rest, we are finding the what we are finding. We are finding the minimum of those elements, and actually, yeah, because those are still strings. So here, this splitting gives you the array of strings, and we are mapping them. We are taking the integer out of those strings. We convert them to integers, and we do that for the slice of all the elements prior to the current item, right? And then we add to the result. What do we add? We add the minimum if it's less than, right? So again, too many parentheses, I believe, right? But I am really worrying about this check because there's only one \d here, and like how can double a number with 2 digits pass this check? Right. Let's run this. Raku, Mohammad, Raku, Ch2, Raku. There's some input already. We use this. This works. I would be surprised if it will not work, but I really want to understand how this works. So there's some string, right? There's this string, and there's this check, right? Actually, I always preferred it like this. Right, I think it should work, right? Raku T. No, I need my. Okay. Right. So let's do it like this, for example, like this, like that. And here, so we have an optional space, an optional comma, and an optional minus sign. So okay, so let's get rid of this minus sign because it's not really important here. Let's get rid of spaces just to remove these from the regular expression, right? But it's wait. So then this will not check because yeah. Okay, let's do it like this, and maybe print this, right? Hey, I mean like this, right? Okay, let's try to understand. Let's remove, like, let's keep it simple. And you see, so 0, because comma is okay, now I understand, because comma is optional. Comma is optional, and it will, yeah, see, so it breaks everything. But if you will put it here, it potentially no, yeah, because the last I see, so because you need it here, so I believe this is, oh my god, so I believe I cannot make it from the first time, so we need something at least 1 or 2 digits separated by comma, right? Yes, so this is the real check. And for example, yeah, so basically, yeah, so it will work for both, and it will work for 2-digit numbers, and you don't need a trailing comma. Right, but you will need it if you will just edit like this, right? Yeah. Okay. Okay, so that's the thing. Good. Going next. But the solution, but yeah, the whole program works. Okay, next solution. Next solution is here. So what we have here, we have this kind of is raw trait, so that we can use this as without any signals. Where, wait, is it? I think. Right, so yeah, but wait, which sliding window? What is it? We are talking. I'm lost. So here we are having this. What about sliding window? Why did process smallest? Okay, okay, let's see. So there's sliding window. Size, we're picking sample process small. Sorry, is it okay? Is it doing the task here, or is it something from different? I'm a bit lost. will create every time. Yeah, this one I remember we're looking. So there are like two simple solution and a difficult solution, and they give the same result. But here, where is our if smallest not defined as smallest but 0? It looks like this is what we are talking about. But okay, let's Raku G or Raku Ch 2. So what do we need? We need 2, 5. Now I'm trying to understand it, right? So it generates some data for us. They look actually alike, but they're a bit different. Right. So we give us so this program asks to give some sliding window size. Then it prepares some random array, this input, right? From this window size 2 powered -1. So if we have 5, it's so it's not powered, it's multiplication. It's from 5 to 9, 5, 6, 7, 8, 9, right? And we pick 5 elements of these. Why? I mean, why this S here and the same S is here? So we start. So if we will give like 10, all the elements will be bigger than 10, right? Right. I didn't quite understand why this. Why not 0 here, for example? And process smallest, and then we print the output by just converting them to integers and printing the Raku representation of this array. Right, so process small. So we've got this list like this one, right? And always return minimum value, current or inclusive. But when called with .raku, return that task2 asks. What task2 asks? Right, so okay, so map, there's this signature of the anonymous code block. And if smallest defined not, if it's not defined yet, right? So because it's nil in the beginning, or if the C, which is the current element, is less than smallest, then the smallest is C, right? So we update the smallest. C but 0. Wow, that's a nice thing. So I think yeah, that's but 0. I never understand how this but works. I mean I know how it works, but I do not feel it. That's the problem. Right, C but 0. So and 0, and I wonder what is 0. 0 is just method Raku. Oops. Roll 0. It's a roll 0, right? Because but is an infix that applies a roll, right? It's not just but. Creates a copy of objects with roll mixed in. So right, so it applies this roll to your thing, and here we apply the roll method Raku. The roll that has the method named Raku, and actually this is the what the comment about. And when we like do it like this, we just get for all the other items which are integers, we got basically the integer itself, and for the 0 we are calling this method. So actually maybe I want to play a bit with this solution. For example, I will do it like 0, and if I will Raku T like 10. Oops. Failure. Why? Yeah, why? Because because we are then converting it to integer. So probably I can just remove this one and keep it 0 here. Right. Or I wanted otherwise just print something from here. But yeah, so that's here you can clearly see that this roll is applied to $C, well, actually to something that we get here in the answer, and yeah, because this one is something that is returned from here. Basically, there's no return, but yeah, we understand that it will be the last computed value, which is the result of map. and basically this is the last computed value on this branch, and here is actually the same, right? Either smallest or this on the second branch. And then we apply this .raku, and we apply this .raku either the built-in code or this code, if we met this condition. Right, okay, going next, and I don't know if if we saw, so 17, yeah, the first element is always 0. I don't understand why the second element is 0, because yeah, right, that's right. The second element is 0 because the 13 is less than everything on left. For these three, the smallest item is 13. It's here. For these three, it's the same. For these three, it should be 0 because 11 is less than all the rest, and so on. Right, so the solution for the last element, the minimum is actually 0, and this 0 is actually this 0, right? Because we start the random array with that 0. I think we should have 0 here. Why we have it like, I think this is better, right? Yeah, I see. So yeah, because we have the danger of having small, really small, like 1, and then we just fill everything with this small item. Okay, that's wise, right? And it's really nice when you understand the intention. Right, that was a solution, and there are 2 more from Roger. Right, so there's some tests directly, and the sub, which takes 0. Then for the rest, if there's well, I believe M stands for minimum, and W, I don't know, width. Right, so that's the element, the previous element, right? And there's this minimum. Right, so for the first time, we just taken something, like the first element, and otherwise we compute minimum, including, you see, so yeah, but basically, so you see, there was a pattern, like when we update the minimum, we immediately assign to this if this minimum is bigger than the current element. But here we're just computing always the minimum of some data, and we add this minimum to this data. So yeah, so just in one go, we will reassign it every time. But the thing is that you don't have any if check here. That's a nice thing, right? Well, yeah, this is about algorithm, but nevertheless. And if it is less than, we are just taking this. Otherwise, we take 0, and again flattening. I don't like flattening, but here it is Raku, Roger, Belwest, Raku, Ch2. Voila, everything works. And the last solution in this series, in this task of this week, is the solution about Ulrich Rieke, and what we have here. So there's lengths and neighbors push. I see. So we actually give even a bit further. So we see that the first element in the result is always 0, and the second element is always the first element of the. Is it the case, or so maybe? We can immediately see it from the solution here, right? So you see, so 0 is always here, and the first element is always the first element, right? The second element, I mean, is always the first element. That's that's really nice. So let's take a look at the solution again. Right, and then we start with already the third element, and we do that for the rest of the array. I is the index here. If all of them are the first element, I didn't understand this. We push 0. Why is this? Why is it? Wait, if all of these are, I don't get that. So this is the slice for all the elements from the very first until the current element, not including the current element, and we compare if all of them are have the same value as the first element, then we push 0. Otherwise, we push the minimum. Okay. There is some idea behind this, which I really don't see that clear. But nevertheless, so let's just run this. So we need to enter something, and to enter this, so there's some prompt, and if you remember, the prompt built-in function prints the message and waits for the input, and then returns. And it returns a string, so you have to make sure that what you get is an integer, and you just convert it to an integer and check if it's an integer, and then you add it. Otherwise, you just ignore this element, right? You ignore it and you end the loop and you type end in the right. Okay, so let's run this. Raku, Ulrich Raku ch2. So we have to. Where is my array? Where is it? It's here. 7, 8, 3, 12, 7, 8, 3, 12, 10, and now end. By the way, what if I will type it like this? Oh my god! Oh my god! Right. Yeah. And I cannot do anything else. So actually, it's looping. You see. Right. Right. So I forgot. 7, 8, 3, 12, 10, and right. Yeah, I think this is not the original data, but let's look at this. So the first element is 0, the second is the first, which is 7. Then there are two minimum. Yeah, so maybe. So after you scan all the solutions, you forgot the data. 783. Wait, 783. No, I didn't forget it. 7, 8, 3, 12, 10. So I believe this is incorrect, right? This should be... okay, so this is what was not clear for me as well from this description. Basically, this condition is not 7, 8, 3, 12, 10. So the input data is 7, 8, 3, 12, 10. This is correct. So, and here we have 7 as the minimum of these two elements, right? So the minimum two elements on the left side of 3, and all the rest are 3s, right? But this is where we have to have 0, which was not actually clear from the result. The only explanation is here. Okay, that was great. There were really a few interesting moments in these solutions of task number 2, smallest neighbor, of week 73 of the weekly challenge. It's not called Perl Weekly Challenge anymore. But it's called the Weekly Challenge, Perl and Raku, but the domain is still Perl. Right. Okay. I hope you enjoyed this. See you next time very soon, and yeah, have a good week.